Hi there, my name is Dimitris, and this is another video of my series focused entirely on the AP Precalculus syllabus. In this video, we will continue our exploration on Unit 1, and more precisely, we will focus on the following topic: the geometrical interpretation of a root's multiplicity. In one of my previous videos, we have seen that by a root's multiplicity, in short terms, we mean how many times, the amount of times that root appears within the function's notation, the function's formula. Now, we will go one step forward, one step deeper to see what could that mean geometrically. And let's go on and reading the things I have already there. At roots of odd multiplicity, the graph of a polynomial crosses the x-axis. That's important. When we have a root of an odd multiplicity, 1, 3, 5, 7, and so on, then we know that graphically, at that point, at that specific number, the graph of the function will cross the x-axis. While, on the other hand, when we have a root of even multiplicity, 2, 4, 6, 8, and so on, then the graph will bounce back. For instance, in the first image we have in front of our screens, you can see that at A, the graph has a root, which obviously has an odd multiplicity. And how do I know that? Well, I can see that the graph intersects the x-axis, cuts the x-axis, moves from under below. Also, in B, graph has also a root. Remember that roots are the points of intersection with the x-axis, with the horizontal axis. But unlike A, in B, the graph bounces back. Do not cross over the x-axis. So we know that at B, that root has to have an even multiplicity. So that's one thing. Odd multiplicity crossing the x-axis, even multiplicity bouncing back. Now, let's try to compare what would happen if we had many odd multiplicities or many even multiplicities. There is this rule. As the multiplicity gets bigger, the graph, and when we refer to odd multiplicities, the graph will certainly cross the x-axis, that's a fact, but as the multiplicity gets bigger, the graph will flatten even more. So I prepared three cases. This is multiplicity of 1. We cannot tell by just looking at it, but I can, because I created that this is a multiplicity of 3. And also, at here, I had created a graph of multiplicity of 5. So you can see in actual example that as the multiplicity gets bigger from 1 to 3 to 5, at that root, the graph flattens even more. The same concept follows when we are dealing with even multiplicities as well. For a fact, the graph will bounce back, but it will bounce back in a flatter, let's call it, way. Here, for instance, I think that I started with x minus 2 squared, where we obviously have a multiplicity of 2. Then I created the x minus 2 to the power of 4, where we have a multiplicity of 4. And here I created the x minus 2 to the power of 6, where again 2 is the 0, but it has a greater multiplicity. Before we are done with this video, note that by just looking at the graph, I can only tell whether the multiplicity is odd or even, because I can easily see whether it crosses the x-axis or bounces back. I cannot, however, estimate the exact value. Although I can see that it has an odd multiplicity, I cannot determine whether that odd multiplicity is 1, 3, 5, 7, and so on. I would need more info for that. And that would be all. I hope I made things easier. If you find this video helpful enough, don't forget to like and subscribe. As always, thank you for watching and thank you for your time.